بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 7.2. We continue in techniques of integration, and today we talk about trigonometric integrals. We will talk about integrals of powers of sine and cosine and integrals of powers of tan and secant. Let us start by sine, integral sine to the power m times cosine to the power n. This is a strategy to evaluate this integral. We have three cases. The first case, if the power of cosine is odd. So we have, for example, cosine to the power 1, cosine to the power 2, cosine to the power 3, cosine to the power 5, cosine to the power 7, odd number. If the power of cosine is odd, without looking to the power of sine, we will take u to be sine x. So we substitute u to be sine x. Put this in your mind. And if you substitute u equals sine x, we will use method integration by substitution. Then what would be du? Du would be the derivative of sine, which is cosine x dx. So you have to arrange the integral in which everything is written in terms of sine except one cosine to be du. So you change everything to sine and you keep one cosine with the dx to be du. So let me give you an immediate example. For example, here, although we don't have sine in this integral, but we can use the same method. Cosine has power 3. So immediately I will let u equals sine x and du would be cosine x dx. So I have to arrange this integral so I can use this substitution. So this is cosine cube, so I write it as cosine square times cosine to the power 1. And now I have cosine x dx, I'll call it du. Cosine square, I need to change it now to sine, to take sine as u. How to change cosine square to sine square? There is a relation. Sine square x plus cosine square x equals 1. This is the most famous relation in trigonometry. So I can find cosine square from here by taking sine square to the other side. So cosine square would be 1 minus sine square x. So that's it. Just replace cosine square by 1 minus sine square. So I will write 1 minus sine square x instead of cosine square, and I have cosine x dx. Now I can use this substitution. The integral would be 1 minus sine x is u, and I have sine square, so I'll have 1 minus u square. And cosine dx is du. So that's it. The integral changed from integral of cosine cube to an easy integral. How to find this integral? Integral of 1 is u. Integral of u square is u cube over 3 plus c. What is u? U is sine. So sine x minus u is sine. So minus sine cube x over 3 plus c. And this would be the integral of cosine cube. So this is when we have power of cosine odd number 1, 3, 5, 7, and so on. Well, the same strategy if the power of sine is odd. So if you find the power of sine is odd, you will take u equals cosine, and then du would be the derivative of cosine, which is negative sine x dx. So you need to take one of the signs, okay, because sine has an odd power. So you take one of them to keep it with the dx, and you change everything else to cosine to take u as cosine x. Let me give you an immediate example. Here, look. What is the power of sine? 5. What is the power of cosine? 2. If the power of sine is odd and the power of cosine is odd, then that's very nice. You can use either strategy 1 or strategy 2. Both will work. But here we have power of sine is odd. So I will take u as cosine x, and du would be negative sine x dx. So how to do this, how to use this substitution? I need one sign beside the dx. So this is sine to the power 5. I write it sine to the power 4 times sine. And I have cosine square. And the sine, I will write it beside the dx. So now this would be du. I just need a negative sign. That's easy to put. But now, what about the others? I have to take u as cosine. So this is okay. I'll take u here cosine. But this is not okay. I have to change it to cosine. So to change to cosine, we use the same formula. We said sine square plus cosine square is 1. So sine square x also could be written as 1 minus cosine square x. So I can write this integral equals, I have sine to the power 4. So this is sine square square. So I have 1 minus cosine square x. This is sine square raised to the power 2 times cosine square times sine x dx. And now I am ready to do the substitution, but I just need a negative sign. I can put it here and the negative sign outside. So I'll have negative integral. 1 minus cosine is u. So this would be 1 minus u square all square. And cosine is also u, so I'll have u square. Negative sine x dx would be du. And now this integral should be easy to evaluate. How can we evaluate the integral? I need to expand this. This is square of binomial. So 1 squared is 1 minus 1 times u squared times 2 plus u squared to the power 2, and that would be u to the power 4, and I still have u squared. So expand again, multiply everything by u squared. So I'll have u squared minus 2u to the power 4 plus u to the power 6 because we add the powers. And now I can find the integral. Integral of u squared is u cubed over 3. And this minus sign will change minus 2 to plus 2, u to the power 5 over 5. And this minus sign will change this plus to minus, and the integral of u to the power 6 is u to the power 7 over 7 plus c. What is u? U is cosine x. So I just write cosine x instead of u. So I'll have negative 1 over 3 cosine to the power 3x plus 2 over 5 cosine 5 cosine x to the power 5 minus 1 over 7 cosine x to the power 7 plus c. So this would be the integral. So now we know what to do. If the power of cosine is odd, we take u equals sine. If the power of sine is odd, we take u equals cosine. What if there is no odd power? If the power of sine is even and the power of cosine is also even, then we cannot use strategy 1 and 2, and we have to use another strategy. And the new strategy is to use these formulas. To write sine square as 1 minus cosine 2x over 2 and cosine square 1 plus cosine 2x over 2. So sine negative in the middle, cosine positive in the middle. By changing this sine square, here we have sine square, here we have cosine to the power 1. So this will make the integral easier to evaluate. Reducing the power from 2 to 1 will help us integrate sine square and cosine square. Let us see example 3. How to find integral sine square? Well, the formula says that sine square equals 1 minus cosine 2x over 2. So this 2, I can take it out, and I have from 0 to pi, and instead of sine square, I can write now 1 minus cosine 2x over 2. The 2 is taken outside. And this integral is easy to evaluate because integral of 1 is x, and integral of cosine 2x, let me talk about this a little. What is the integral of cosine x dx? The formula says that the integral is sine x. The integral of cosine is sine. Why is that? Because the derivative of sine is cosine. Now, what if I have a question like this? Cosine ax plus b. So instead of x, I have ax plus b. Well, the answer would be sine ax plus b. So similar to this, just instead of x, I have ax plus b. But you need to divide by the derivative of ax plus b, which is a. So the integral of cosine ax plus b would be 1 over a sine ax plus b. So here I have cosine 2x. So the integral of cosine 2x is sine 2x over the derivative of 2x, which is 2, from 0 to pi. And that's it. You can just replace x by pi minus sine 2 pi. Sine 2 pi is just 0. Okay. Then minus, we replace now 0, 0, minus sine 0, 2 times 0, 0. Sine 0 is also 0. So actually the answer is pi over 2. Another example. What if we have sine to the power 4? Again, there is no odd power here for sine or cosine. So we should use the formula. We should change sine square x to 1 minus cosine 2x over 2. But I have sine to the power 4. No problem. It is sine squared to the power 2. So write it 1 minus cosine 2x over 2 to the power 2. And now expand. So this 2 when raised to the power 2, I'll get 1 over 4, and it's a number I can take it out. And now I need to raise 1 minus cosine 2x to the power 2. So 1 square is 1 minus 2 times 1 times cosine plus cosine square 2x dx. Well, the integral of 1 is easy, the integral of cosine is easy, but cosine square, I don't know how to find the integral of cosine square. But I know that if I have cosine square and I need to find its integral, I have to use this formula. Cosine square x is 1 plus cosine 2x over 2. But unfortunately, this is not cosine square x. This is cosine square 2x. So if I have x here, I have 2x here. So if there is 2x here, I'll multiply by 2. So this x is multiplied by 2. So 2x will be multiplied by 2, and it would be cosine 4x. And instead of 2x, I'll have 4x. So this would be cosine square 2x. So I can write this integral as 1 over 4 integral 1 minus 2 cosine 2x plus cosine square is 1 over 2. I can distribute the numerator over the denominator, 1 over 2 plus cosine 4x over 2, or half cosine 4x dx. And now I can evaluate, but I can just add 1 with half. So I have 3 over 2 minus 2 cosine 2x plus half cosine 4x dx. And this integral is easy. The integral of 3 over 2 is 3 over 2x minus 2 times. Integral of cosine 2x is sine 2x over 2. That's what we mentioned here. Okay. We divide by the coefficient of or the derivative of 2x. And here I have 1 over 2 times integral of cosine is sine 4x, and I divide by 4 because the derivative of 4x is 4. So that's the answer, plus C. Just arrange. So 1 over 4 times 3 over 2 would be 3 over 8x. 2 cancels with 2, and I'll have negative 1 over 4 sine 2x. And here, 1 over 2 times 4, 1 over 8. And there is 1 over 4 here. So I'll have 1 over 4 times 8, or 32 sine 4x plus c, and this is the integral. Now, what about powers of secant and tangent? Okay, we know that sine square plus cosine square equals 1. We have seen that. Now, if you divide all terms, all the 3 terms, by cosine square, so divide by cosine square, what would you get? Sine square, sine over cosine is tan. So sine square over cosine square would be tan square. This is 1. 1 over cosine is secant, but we have cosine square, so it will be secant square. So we have a relation between tan square and secant square. And we can use this relation to change tan square to secant square and secant square to tan square. So we can deal with this integral, tan to the power m, secant to the power n. And now we have two strategies for two cases. The third case has no strategy. You have to think about it. So what is the first strategy if the power of secant is even? So if you have secant to the power 2, 4, 6, then you take u as tan x. And then du would be the derivative of tan is secant square x dx. So I need secant square beside the dx, and everything else should be in terms of tan. So I take tan equals to u. Let us see an example. I have tan to the power 6, secant to the power 4. I have secant to the power 4, so immediately I write u equals tan x. And then du would be secant square x dx. And I need to change the integral so I can use this substitution. So to do that, I have tan to the power 6 and secant to the power 4, I will write it. Secant to the power 2 times secant to the power 2. So this I need to keep to be du. And I need to take tan x as u. So I have no problem with this. I'll take it as u. But secant square is not welcomed. I have to change it to tan. So I take it as u. So how to change secant square to tan? This is the formula. Secant square is tan square plus 1. So I write it integral tan to the power 6 times secant square is tan square plus 1. And this secant square, I keep it with the dx. So now I can change to u. I can take u tan x. So I have here u to the power 6 and here u to the power 2. And secant square x dx would be du. And now this is an easy integral. You expand, you have u to the power 6 plus 2, 8. And u to the power 6 times 1 is just u to the power 6. And the integral would be u to the power 9 over 9 plus u to the power 7 over 7 plus c. And what is u? U is tan. So the answer would be 1 over 9 tan x to the power 9 plus 1 over 7 tan x to the power 7 plus c. And that's the answer. So we know what to do if the power of secant is even. What if the power of tan is odd? Okay, and this is the second strategy. If the power of tan is odd, we take u equals secant. And if you are going to take u equals secant, then you have to think of d of u. The derivative of secant is secant x tan x dx. So I have to have secant x dx, secant x tan x dx in the integral. And I will take u equals secant, so everything else should be in terms of secant. Let us take an example. Example 6. Power of secant is 7. Not good. I need it to be even. But power of tan is odd. That's good. If power of tan is odd, then immediately I write here u equals secant x. And du would be secant x tan x dx. And once I have this, I arrange the integral so I can use this substitution. So I have no problem with secant because I will take it as u, but this tan, I need to do something. What? First, before changing tan to secant, I'll take one of these tans, so I will have tan 4 theta. One of them, I will write it here, beside d theta, because I need tan x dx. I need also one secant. So secant to the power 7, I take one secant and keep it here. And then I have secant theta to the power 6. So this one is good now. I can take it as du. Secant is good for me. I can take it as u, but I have problem with tan. So I should change tan to secant. What is the relation? We have seen that tan square theta plus 1 equals secant square theta. But I need to change tan to secant square. So I can write tan square theta as secant square theta, and I take the 1 to the other side, so minus 1. So tan to the power 4 would be tan square to the power 2, and tan square is secant square theta minus 1. This is tan square, but I have tan to the power 4, so I raise this to the power 2, and I have secant 6 theta, which I am okay with it, and I have secant theta tan theta d theta, and now I arranged everything and I am ready to use the substitution. So secant would be u, but I have u square because secant square, and secant would be u, but I have power 6, and secant tan d theta is just du. So I can solve the integral easily. First, I need to expand this. So I'll have u to the power 4 minus 2u squared plus 1 times u6 du. Now I have to expand the u6, multiply. So u to the power 6 times u to the power 4 is u to the power 10. U to the power 2 times u to the power 6 is u to the power 8. And 1 times u to the power 6 is u to the power 6. And now I can find the integral. This is u11 over 11 minus 2u9 over 9 plus u7 over 7. And I can replace u by secant. So the final answer would be 1 over 11 secant 11 theta, I believe, or x. Yeah, it should be theta because everything here is theta. So this is theta, 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 even theta, d theta. Minus 2 over 9, u to the power 9 would be secant theta to the power 9, plus 1 over 7, u to the power 7 would be secant theta to the power 7 plus c, and that's the answer. All right. So we have learned what to do if the power of secant is even or the power of tan is odd. Now, if the power of secant is not even and the power of tan is not odd, so we have something like integral secant square x, no, secant cube, because if the power of secant is even, I can use this strategy 1, and this is tan square dx. So here the power of secant is not even, the power of tan is not odd, but here we need to use think substitution. Maybe we need to use integral of tan, this one, and we can memorize this integral. We found this integral before, we just wrote it sine over cosine, and we took cosine as u, so the answer would be uh, len u, or len negative len cosine, and then we can write it len secant. Negative len cosine, you take the -1 to the power and you write it len secant. Sorry, alhamdulillah. Also, I need, maybe I need this one, integral of secant. You can also memorize this formula, although we can prove it, but the proof is not that easy. Okay, to find the integral of secant x dx, you need to do something, some uh, trick here, small trick. I multiply by secant x plus tan x over secant x plus tan x. What happened if I do this? I'll have multiply, I have secant square, secant times secant, plus secant times tan in the numerator. And in the denominator, I have secant x plus tan x dx. And now, if you look to the denominator, the derivative of secant is secant tan, and the derivative of tan is secant square. So I can take u as secant x plus tan x, which is the denominator, and du would be derivative of secant, which is secant tan, plus derivative of tan, which is secant square times dx. So this integral would be equal to, all of this is du, and the denominator is u. So the answer is len u plus c, and u is secant tan, secant plus tan. So the integral of secant is len absolute value of secant plus tan. Okay, you can just memorize it and use it whenever you need it, wherever you need it. So integral tan, integral secant are there. Let us try to solve this integral. What do we have? Power of tan is odd. That's good. If power of tan is odd, I'll try to take u as secant. That's our strategy, yes? But du would be secant tan. Okay, I can take one of the tans out, but I don't have secant in the question. So this will not work here. Let us try to write it, still write it as tan square x times tan x dx. And now I cannot use this formula because I don't have secant in the question. If I change tan square to secant square, we said that tan square plus 1 is secant square. So tan square is secant square x minus 1 times tan x dx. So you can consider this example a special, not like this, okay? So now we can multiply, expand. So I'll have secant square x times tan x dx minus 1 times tan integral tan x dx. So I made them two integrals. This integral, the first one, is easy because the derivative of tan is secant square. So I can take u as tan x and du as secant square x dx. So it would be integral of secant square dx would be du and tan would be u, so u du. And this is u square over 2. And u is tan, so it's tan square x over 2. So in fact, this integral would be half tan square x. And integral tan is ln secant x. We have just seen that integral tan is ln absolute value of secant x. And we then put plus c. So we used integral tan. So this is how to find integral of tan to the power 3. Well, secant to the power 3 is more difficult than tan to the power 3. And to find this integral, I will write it secant x times secant square x. The power of secant here is 3, so it doesn't follow the strategy. So what to do? In fact, we use here integration by parts. I take u to be secant x, and then du would be derivative of secant is secant tan. And I take dv as secant square x dx. And the integral of secant square is tan because the derivative of tan is secant square. So this integral would be equal to uv secant x tan x minus integral v du, which is secant tan times tan, or secant x tan square x dx. And how to find this integral, the new integral? Well, I will write tan square as secant square minus 1. So this would be secant x tan x minus integral secant x times secant square x minus 1. And then I will have secant x tan x minus integral. Secant times secant is secant cube x dx. I'll make them two integrals. Minus times minus would be plus secant dx. secant x dx integral, of course. So what do I have? I have integral secant cube x dx equals, which is this one, equals what? Secant x tan x plus. What is integral of secant x? Len secant x plus tan x. We have just seen this, the formula. Minus integral secant cube x dx. And this is exactly the same integral, the original integral. We have seen this situation when we found the integral of ex times sine x or ex times cosine x. So what to do? I'll take this integral to the other side. So I will have 2 integral secant cube x dx equals all of this, and then I divide by 2 to have the integral of secant cube. So the integral of secant cube is half times secant x tan x plus ln absolute value of secant x plus tan x. And then I can add plus c. Nice integral. I hope you enjoyed trigonometric integrals.